Hey guys, today we're going to be talking about graphing systems of linear inequalities. Now, a few days ago we graphed systems of equations, and that was just graphing more than one line on the same coordinate plane. And what we looked for is their intersection point, and we said the intersection point was the solution to that system. Well, the same is true for graphing systems of linear inequalities. When we graph an inequality, remember we shade a half plane on that coordinate plane, and that represents the solutions to that inequality. So when we graph a system of inequalities, we're looking for the overlapping half planes, and that's going to be known as the feasible region. That feasible region will find our solutions to that system of inequalities. Now, if our half planes don't overlap, we say that the solution to that system of inequalities is known as the empty set. Let's take a look at our first example here. We're going to graph each one of these and pay attention to the inequalities. We want all the y's that are less than or equal to negative 1/2 x plus 6. So we're going to start on our y-axis and come up here to our y-intercept of 6. And then we're going to use our slope, which is negative 1/2. We're going to come down 1 and run 2, down 1, run 2, down 1, run 2, down 1, run 2, down 1, run 2. And there you have the slope of that line. So we are going to draw it in as a straight line. And keep in mind that we want all the y's that are less than or equal to that line. So we're going to shade below that line. All right, so let's just put some blue in there. All right, now we are going to switch to yellow. We're going to graph the line y is less than or equal to negative 2x plus 12. So if this is 6, 7, 8, 9, 10, 11, 12, here's my y-intercept. And now I'm going to come down 2 and run 1, down 2, run 1, so on and so forth. And again, we want all the y's that are less than or equal to it, so this is going to be a solid line. So we'll connect all those points with a solid line as best we can, and we're shading to the left of that. So you can start to see here that we have some shaded half planes that are overlapping each other. Next, we want all the y's that are greater than or equal to 0. So all the y's greater than or equal to 0 are anything greater than the x-axis. So this indicates anything above the x-axis. So now I'm going to shade this part here, and we'll switch back to blue here. And now the last one is we want all the x's greater than or equal to 0. So that's to the right of the y-axis here. So that is this shaded region right here. And so you can see where all 4 of those half planes overlap. And this is what's known as the feasible region. So let's just kind of carefully go around to the vertices of this feasible region. So this vertex right here that I'm pointing to was the y-intercept of our first line. So that is at 0 over and 6 up. All right, let's go down to the origin. That's another vertex that we have of this feasible region. That's 0, 0. And then if we come across the x-axis, we see that this is 1, 2, 3, 4, 5, and 6. So here's another vertex of this feasible region, and that's at 6 over and 0 up. And then finally, we have this point here where these two lines intersected. So that's at 1, 2, 3, 4 over, 1, 2, 3, 4 up. So these are the vertices of this feasible region, and it's in this overlapping area where we will find solutions to this system of linear inequalities. All right, let's take a look at another example. Now we just have 2 inequalities to graph here. Let's start off by graphing the bottom one actually. We have y is less than or equal to negative 2/3 x plus 4. So let's climb the y-axis here to 4. Here's our y-intercept. We're going to come down 2 and run 1, 2, 3. Down 2 more and run 1, 2, and 3. So again, these are all the y's less than that. Therefore, this is going to be a solid line going through those 3 points. And I'm shading everything to the underneath that line there. Okay. So the next one we're going to graph, and we'll change over to blue here. We want all the x's greater than or equal to 0. So that indicates everything to the right. So that is everything even below the x-axis, but just till we get to that line there and away from the y-axis. So you can see where these two overlap. And what we have here are the vertices, this y-intercept of our first graph, which is 0 over and 4 up. That's the vertice of one region. And then this triangle is just going to keep extending further down to the right because this yellow line will keep going on further to the right. So we really only have one point, and then this entire feasible region will continue to grow, and that overlapping half planes will be the solution to this system of linear inequalities. All right, let's take a look at one more example here. We have the Zealand dance program that's selling flowers. They're selling baskets of geraniums and petunias and plan to sell all the plants they have. Their profit on each basket of geraniums is $4, and on each basket of petunias is $2.50. So if the dance team wants to make at least 500 or more, how many baskets of each must they sell? So we're going to set up some variables here. Let's let G equal our number of geraniums. I probably won't spell that right. And then P equals the number of petunias. All right. Now, we want to sell, first of all, we want to sell all of them. So we know that the number of geraniums has to be greater than or equal to 0. And same thing with the number of petunias. That also has to be greater than or equal to 0. So we're just, for this example, going to let our G be our number of geraniums here. So this is going to be plotted along the X, and our P is going to be plotted along our Y. So this is our geraniums, and this is our petunias over here on our axes. Okay, now we know together that $4 is made on each geranium and $2.50 is made on each petunia. So let's write this profit equation here that says 4 times G plus $2.50 times P, and we want that profit to be greater than or equal to $500. All right, so here is our system of linear inequalities. These first two here just indicate that we're going to be graphing in quadrant 1, and this second one here now is going to be our line. So let's take a second to set up our axes here, and we're just going to jump by 20s along the y-axis, and we'll jump by 20s along the x-axis as well. Okay, now that we have our axes labeled, let's go ahead and find our intercepts. Remember how to find intercepts from last chapter. If we want to find our g-intercept, that is our x-intercept, we're going to cover up or substitute 0 in for p. Take 500 and divide it by 4, and you're going to get 125. So that's approximately right here. There's our g-intercept. Next, we're going to find our p-intercept. So cover up the g term, take 2.5p and solve for p. So 500 divided by 2.5 is going to give us 200. So there's our y-intercept. Now, keep in mind this is a solid line because it has to be greater than or equal to. So we are going to connect those intercepts like this. And remember, we want the profit. So this line indicates where the combinations of petunias and geraniums that actually have a profit of 500. But we want greater than it, so we want everything shaded above that line, so to the right of it in this case. Now keep in mind our other two inequalities were where G is greater than 0 and P is greater than 0. So P is greater than 0, or sorry, G is greater than 0 is everything to the right of this line. So the overlap begins right here. And where P is greater than 0 is above our x-axis. So that overlap begins right here in this region. So our feasible region here exists outside this line, or I should say above this line of profit. And so any point out here will be a point in which their profits exceed $500.